Yesterday we have discussed electric dipole in live classes. So again we write here electric dipole. Electric dipole. How can I define electric dipole? A pair of equal and opposite charges separated by a small distance, minus q plus q charges, and separation may be assumed as 2a. This is separation between these two charges. Charge minus q, then plus q, separation 2a. A related separation, and this one is charge minus q plus q. We have to discuss another term related to electric dipole, that is electric dipole moment. It is a vector quantity. Its magnitude is equal to product of magnitude of either charge into separation between them, q into 2a, represented by p, vector p. It is equal to 2qa. So dipole moment is a vector quantity. Its value is product of magnitude of charge and separation between both the charges. It will be 2qa. Now since it is vector quantity, so direction is along the axis of dipole. Axis है minus q to plus q, ये axis है. From minus q charge to plus q charge, and direction is along the axis, so you can write here along the axis. Dipole moment, product of charge and separation, direction along the axis from minus q charge to plus q charge. So these are two terms, you should remember it. Now we have to derive formula of torque. Torque acting on an electric dipole placed in a uniform electric field. So this we have to derive. Torque acting on an electric dipole placed in an uniform electric field. Now uniform electric field can be represented by parallel lines like this. Parallel and equidistant lines. Suppose electric field is E, vector E, it is uniform electric field. A dipole is placed in this uniform electric field. As we know, charge on dipole minus q plus q. Length is 2a. This is 2a. Now suppose dipole AB. Mark direction of dipole moment along the axis from minus q to plus q. Minus q to plus q. It is vector P. Dipole moment. Suppose this dipole moment makes an angle theta with the direction of electric field. P makes an angle theta with direction of electric field. Now as we know, E equal to F upon Q. So what will be force on charge? Q into E. Charge placed in electric field, force acting on it is QE. Now you should remember direction of force also. at direction of force on plus Q charge. It is in the direction of इलेक्ट्रिक फील्ड E, वेक्टर E के डायरेक्शन में होगा. नाउ डायरेक्शन ऑफ फोर्स ऑन माइनस Q चार्ज, इट इज जस्ट अपोजिट टू द डायरेक्शन ऑफ E, अपोजिट टू द डायरेक्शन ऑफ E, वेक्टर E. तो ये फोर्स प्लस Q पर फील्ड के डायरेक्शन में, प्लस Q चार्ज इन द डायरेक्शन ऑफ E, और माइनस Q पर फील्ड के अपोजिट डायरेक्शन में. यू शुड रिमेंबर ऑलवेज दैट प्लस Q चार्ज पर फोर्स फील्ड के डायरेक्शन में एक्ट करेगा, मैग्नीट्यूड बाई QE, ये हुआ QE डायरेक्शन इलेक्ट्रिक फील्ड का, और माइनस Q पर जस्ट अपोजिट टू द डायरेक्शन ऑफ फील्ड, ऐसे मार्क करेंगे. मैग्नीट्यूड यहाँ भी वही है QE, बट डायरेक्शन जस्ट अपोजिट. इन दोनों फोर्स के डायरेक्शन जस्ट अपोजिट टू ईच अदर है. इनके लाइन ऑफ एक्शन अगर मार्क करने हो तो ये लाइन ऑफ एक्शन होगा दोनों फोर्सेस. अब नेट फोर्स हम लोग फाइंड करें कि डाइपोल पर यूनिफॉर्म इलेक्ट्रिक फील्ड में कितना नेट फोर्स है. नेट फोर्स ऑन डाइपोल, दैट विल बी QE माइनस QE. डायरेक्शन अपोजिट हैं तो एक प्लस एक माइनस, दैट विल बी 0. सो you should remember this, that net force on dipole in uniform electric field is 0. डाइपोल है, इस पर दोनों फोर्स इक्वल इन मैग्नीट्यूड हैं, अपोजिट इन डायरेक्शन है, लाइन ऑफ एक्शन इनका कोइंसाइड नहीं कर रहा है. सो दिस टू फोर्सेस विल फॉर्म अ कपल. वी कैन राइट हियर, सिंस forces acting on charges plus Q minus Q plus minus Q, charges are equal in magnitude, but opposite in direction, and their lines of action do not coincide with each other. Then what happens? These two forces form a couple. So these two forces form a couple. If torque of couple is tau, then we can find the value of tau. See here, these two forces equal in magnitude, opposite in direction. Their lines of action do not coincide. So these two forces form a couple. Torque is tau. Then we can find the value of tau. See here, this torque tau, its magnitude is equal to magnitude of either force into perpendicular distance between their lines of action. So draw perpendicular here, BC, from B to C. You can write here C. This is perpendicular. BC is perpendicular distance between lines of action. So tau equal to QE, magnitude of force. Perpendicular distance is BC. Now we can find the value of BC from this triangle. From triangle ACB. from triangle ACB, sin theta, it is equal to BC upon AB, that is equal to BC upon 2A. So BC equal to 2A sin theta. Now put the value of BC. Tau equal to QE into 2A sin theta, that will be 2QA into E sin theta. Now you know 2QA. Previously we have discussed, say, dipole moment. So 2QA it is equal to mod P, या simply P भी लिख सकते हैं. So tau equal to PE sin theta, it is magnitude. In vector form we can write vector tau equal to vector P cross vector E. E and E both are vector quantities. Vector tau equal to vector P cross vector E. In case of cross product we write sin theta. So this is formula of torque. P sin theta मैग्नीट्यूड फॉर्म में और वेक्टर फॉर्म ये हो गया, वेक्टर टाउ इक्वल टू वेक्टर पी क्रॉस वेक्टर ई. नाउ वी हैव टू डिस्कस सम स्पेशल केसेस. If dipole is placed either parallel or anti-parallel to the electric field, that is theta is either 0 or 180. In that condition, tau PE sin 0 or PE sin 180. You know the value of sin 0, sin 180 both are 0, so torque will be 0. We can show the dipole in electric field. Charge is minus Q plus Q. It is placed parallel to electric field. Forces QE और माइनस चार्ज पर QE. लाइन ऑफ एक्शन दोनों का देखिए एक साथ कोइंसाइड कर गए, इसलिए कोई कपल फॉर्म नहीं करेगा. अगर कपल नहीं है तो कोई टार्क एक्ट नहीं करेगा. सो इन दिस कंडीशन देयर इज नो एनी टार्क एक्ट ऑन डाइपोल, and if theta equal to 90 then torque will be maximum. So we can write tau equal to tau maximum, that is equal to P. So these are terms. Torque पैरेलल एंटी पैरेलल पर टार्क 0 होगा, बाकी 90 डिग्री पर मैक्सिमम टार्क है. नेट फोर्स हमेशा यूनिफॉर्म इलेक्ट्रिक फील्ड में 0 होगा. टार्क के लिए सिचुएशंस के अकॉर्डिंग हम बताएंगे. टार्क का ये फार्मूला. थैंक्स.